study. You're terrible. Yeah. I did my master's degree in Madison, Wisconsin. It's maybe minus 20 or 30 centigrade. Very, very cold. 零下30度、20度 so cold. All right. Okay. Last week we derived the Gaussian equation for the beam, right? Or the theory. And beams like this. Okay. Define the x-axis and the output distributed loading 2x. Okay. And this is my diffraction. Yeah. And this is the EI as bending rigidity. So the Gaussian equation is EI W post derivative equal to 2x. This is my Gaussian equation. Right? Or you like is minus EI W. Second derivative is equal to moment. Okay. Right? So this is my two types of equation. If you can write the internal moment distribution along the beam, and you can, so this is can be done by solve, by integration. Okay? Direct integration 4 times, you can get a displacement, right? But you have 4 integration constants. So those 4 integration constants will be determined by the boundary conditions, right? This only need to integrate twice. You can get the displacement, okay? We can get Wx twice. But this is it twice, so you have a 2 integration constant to be determined. Okay. So this will have a 4 integration constant to be determined by using the boundary conditions, right? So 4 integration conditions you have, you need to 4 boundary conditions, right? This will have 2 integration constants. You need to 2 boundary conditions. Okay. So for nth order ordinary differential equation, nth order, the highest differential order of the boundary condition is n minus derivative. Right? Nth order ODE, the boundary condition can reach to only to n minus 1 order. So for this case, this fourth order is boundary condition, the highest is still to the third derivative. So that's what? We know minus EI double prime is equal to moment, right? And minus EI, third derivative is equal to shear. Okay? So the first equation you can use here to W, the third derivative, I mean the shear boundary condition. For that one, the boundary for this one, you only can use the W and the W first derivative as the boundary condition. Okay? This is the second order. So highest derivative of the boundary condition is first order. Okay? So let's see the boundary condition. First one is we call the free end. Free end. Okay. For example, this is a free end. This is free end. So what the boundary condition? Boundary condition is moment equal to 0, right? So that means minus EI. And S equal to, for example, this is L. And L equal to 0. Right? So that means we have a W double prime and L equal to 0. Because our Gaussian equation is in terms of displacement. So you have to write your boundary condition in terms of displacement. Okay? And also we have a shear equal to 0. So minus EI triple and L equal to 0, or triple and L equal to 0. This is my boundary condition. Okay? And the boundary condition at here is W at 0 equal to 0, and the slope, rotation at 0, 0. Okay? Right. Okay. Right. And for free end, okay? Then second is pin. This is simply supported. Support. Simply support. So here, the moment at 0 equal to 0. Okay. And that means that the W. Okay. And also diffraction at 0 equal to 0. So here we have a diffraction 0 and the moment. Okay. Did you learn this before? 学过吗? And yeah, third is fixed end. This is a fixed end. And here, W 0 equal to 0, W slope and 0 equal to 0. And number 4 is called clamp. Clamp, okay? It's like this. This is can be sliding inside a slot. Yeah. So this kind of boundary condition is the slope dw dx equal to 0. Okay. Okay. And what else? And shear equal to 0. No shear. Okay. It's very special. Cannot rotate. This beam here cannot rotate. And shear force. No resistance, no reaction of shear. Okay? So shear is a very special condition. Yeah. So yeah, if you use a moment here, the boundary condition you cannot use because the boundary condition here is second order and third order. So you cannot use this kind of boundary condition. If you use if your boundary condition is EI, W double prime at equal to moment. Okay. So, but here you have only two constant, two unknown constant, but you can use the two boundary condition here. Okay, so either way. So I see if we can show you. Okay, maybe we can do one example.